I would like to make a couple of apologies before I start. The first is my slides are very simple. I'm not here to sell boxes. I'm here to sell ideas. And the second is I will not say the word OpenFlow after this first time that I said it. I was going to thank Sanjeev for not saying it, but then he said it a few times, so sorry,
Well,
Sanjeev.
they asked me.
They didn't? You are. So what I want to talk about is the paradigms that we have for SDN. And I want to start with the fundamental problems that we're trying to solve in networks, the operator pain that we see. And then talk about some of the paradigm shifts that we have in our whole approach to networking. And then look at two models of SDN, SDN as an operating system and SDN as a compiler. And then to make this somewhat more concrete, give an example. And in fact, the example will align nicely with what Frank and Elisa talked about. And then, conclude. So the fundamental problems that we see operators talking about, and we see this from multiple operators, and not just in service providers, but also enterprises, also in data centers. We want more innovation in networking. We want to be able to roll out new services, do new things with our networks, and we want to be able to do it quickly. This is a very common requirement that people are saying, our networks have become very rigid. They don't react to things quickly. For us to do new things takes too long. And sometimes it costs too much, not just in time, but also in being able to do it. We have to change too many things to make a new service available. The other thing that we see is I want a lot more control over my network. I want control over where my traffic goes. I want control over services. So the example that Frank talked about, I want to be able to chain things. I want to customize it for a particular user or group of users. So it's, control over devices, control over ports, but really control over traffic and control over services. I want more abstraction. We actually dive too deep too soon, and I want to be able to step back and understand what my network is doing. Actually, sometimes it understand what I think I'm doing, and then figure out what you're really doing. So that's where the last one comes in. We want more visibility, and we want visibility down from the low layer to understand, packets and bytes and stuff, all the way up to what are my services doing, how are my customers actually appreciating my network. So there's a specification of what I would like to see in the network, and there's the actuality what's in the network, and we need to bring them all together. So here are some fundamental problems that we need to solve, we need to tackle, so that operators, whether operators of service provider networks or operators of enterprise networks, or even operators of data center networks, can really be more effective in doing what they need to do. So I think SDN, and yesterday we were trying to define SDN, I don't really care for what the letters SDN stands. I think SDN is really a movement. And the first big thing, the first constructive thing that SDN does is this paradigm shift away from boxes and to the network. We really need to stop thinking about the boxes and ports and things that make up the network, and actually look at the whole network. So the elements that you see in a box today may get pulled out of the box and may get distributed in different ways across the network. They'll all be there, and maybe there'll be new elements, but it's really important that we step away from the box and really look at the network. So in order to examine this paradigm shift, I'm going to look at two models of SDN. The one that most people talk about is the paradigm of an operating system or a network operating system. The one that I'm going to focus on is the paradigm of a compiler. So I'll describe each, and I'll try to score them, and I'll, of course, give myself very high marks, which is, But I will leave it to you to really do the scoring. And then to illustrate the SDN as a compiler paradigm, I will take some examples. So the usual thing that people say with SDN is, I need to separate the control plane and data plane. I'll centralize the control plane. I'll present this control plane as a network OS. In the process, the data plane might become really dumb, but we've seen in Eric's talk, we've seen indications that maybe you don't want it really dumb, but at least the initial paradigm is the data plane becomes really dumb, intelligence goes into the centralized control plane, and this control plane presents some APIs that you can then use to write control programs to place the traffic where you want, to create new services, to create service chains, et cetera, et cetera. The paradigm here is that this network OS will give you the facilities, the services that you need to do all this. And what you're expected to do with this is to write imperative programs that say, do this, do this, do this, and a new service shows up or traffic goes where you want it to go. So essentially, the network OS is like a regular OS, except it's network-wide. It gives you a common view of the whole thing. And where normal OS would give you scheduling, memory management, and so on, this OS will give you a set of interfaces. We haven't defined them yet, but think of this as a new POSIX, where it'll tell you, here's what your network looks like, here's the topology, here's the current state of different devices, ports, links, and so on. And now I can use this so that I can have access to things across the network rather than looking box by box. And so the control program is thought of as a transformation from the current state of the network, which the network OS presents to me, to the desired state, which might be move the flow from here to there or create a new service somewhere else. And so essentially a control program is a transformation from the current state of the network to a desired state. So the fundamental abstraction that you're working with is the network as an annotated graph. The nodes are the devices in the graph. The links are the connections between these nodes. And they're annotated with different things like capacity or latency or something else. And at the end of this, I look at the whole network as the current state, and then I try to transform it. How do I reason about this? Well, I have control programs, and they're essentially transformations. One of the things, though, is in presenting this model, people said, we don't have enough network abstractions, so we're going to use this as an abstraction. It starts off looking nice, but then when you say my control programs are transformations, and then I'm given two control programs, and you ask me, what is the net result of these two control programs operating on my network state? One of them, yes, it transforms it from here to there. So here's the current state, here's the desired state. The other one says, here's the current state, here's the desired state. When I put them together, can I really reason about this? Do I know what the end state is when I'm running multiple control programs, especially when those control programs are C programs or Java programs that are trying to change the network? How do I know this is correct? Again, it gives you a way to talk about correctness because I'm not talking about boxes anymore. I'm abstracting all this into a common view of the network. But how do I analyze these network transformations? Essentially, I'm going back to program correctness. And I love program correctness, but in the end, it turned out to be a useful way of reorganizing how we write programs, but not really a useful way of proving that programs are correct, because the proofs are often longer than the programs themselves. And as I just said, if I have multiple of these control programs working together, how do I actually anticipate how services interact? I'm trying to offer a video service here. I'm trying to offer a data center interconnect there, and both of them need a lot of bandwidth. How do they interact? Where do they interact? Is there actually a place where I'm causing congestion or latency that one service will affect the other? You can do this, probably. You have to develop a calculus of network transformations and say, this program is doing this transformation, this program is doing this other transformation, here's how they work together. in the end, though, while we're looking for this abstraction, while we're looking for being able to reason and anticipate service interaction, I think this becomes quite hard to do. It's still a lot better than trying to do it box by box. So if I score this and a check mark being, yeah, we did a good job here, and a cross being, we still need to do some work, I essentially say that we want more innovation, we can get more innovation because now we can step away from the boxes in the network and try to do something. But I'm not sure you can do it quickly because people underestimate the difficulty of writing programs and making sure the programs are correct and doing the right thing. We want more control. This gives you more control. But again, it's a very difficult way of getting that control. We want more abstraction. Yes, we have this abstraction of the network as a graph. But how do I understand what I'm doing? By reading a program. Again, I think that's a huge improvement over reading CLI across 100 boxes, but I'm not sure we're there yet. And for visibility, I don't think we've even scratched the surface. So don't get me wrong. I think the people who started SDN did us a huge favor. In some sense, they woke us up from our deep sleep and said, here's things you got to work on. But I think the approach today is too low level, and we need to step back from it. One thing that I enjoyed in Eric's talk was, while he said OpenFlow many times, he did say that people are building higher level approaches on top of that. I just want to start from the top and then go down. So, and as I said, we don't talk about visibility much in this approach. The second paradigm of SDN, the one that I want to talk about more, is SDN as a compiler. And it's not a perfect analogy. People say, what's the difference between an OS and a compiler? If you look at something like Java, it's a system, it's a language, it's a compiler, it's a runtime, it's a whole bunch of things. I think the distinguishing thing that I want to focus on is something that's very high level and something that's declarative rather than imperative. Essentially, you say what you want. You don't say how to do it. Somebody else takes care of how to do it. It's what people have been talking about so far, programmatic interfaces and control programs and so on. You have to say, do this, do this, do this. Look at this current state of the network, move it to this state. I'd rather go with, give a high-level view of specification of what I want to see in the network, and then have the SDN system go off and do it. And notice that I say SDN system. I don't see this as a single controller. I'm not going to have a long debate with someone from some company asking, where does everything fit? But I do think that there are components here that are centralized, there are components that are distributed, there are components that are more about management, there are components that are about distribution. And the data plane at the bottom is not dumb. I don't think it should be dumb or it needs to be dumb. But the system overall, interacting together, says, oh, you want this to happen? I'll go make it happen. And so this is the paradigm that I think we should explore some more and see how that actually fits in. So the style of SDN, this model, this paradigm, essentially says, I'm going to give you an abstraction of a high-level declarative language. And in that language, you state what you want to see in the network. And I'll give you some examples in a couple of minutes. So the network administrator's job is not to start writing C or Scala or some language, but to write something that says, here's a service I want to create. Here's a service chain that I want to create. Here's a set of users that I want to see having this service chain. The SDN compiler, the SDN system, has to translate these high-level things down to low-level instructions for the boxes. But you'll see that my low-level is actually not low-level. It's the appropriate tool for the particular case.